about it. All right, so we have our, we're on number 16. Again, this video is, if it would load, we're doing the practice final. We've already done the first 15 questions. We are on number 16. Let's zoom in here. We are rewriting these logarithms in one log. If I'm subtracting the logs, that means I'm doing what operations with the insides? Dividing, which means I have log of 3. If I don't have any base, I assume that this base here is, assume 10. Thank you, Andrea. All right, what about this other rule? I need to write this without any coefficient. How do I do that? Who's got it? I don't want a coefficient. James, go for it. Close. It's not times. It's log of 4 something.
Wait, why did you multiply it by 3x14?
Those are for problem number 15.
Oh.
That was from yesterday.
I was confused.
Obviously, if you have log of 6, you have to multiply that by 3x plus 14 or plus 4.
Wait, why don't you assume 10? Assume 10 what?
Assume a base of 10. Because logarithms, you always have a base. So log base e of something is technically the natural log of x, right? Those are things that we have seen in our past. So,
Can I ask you a question?
if it's related to math.
I don't know.
So no, wait until we're done with this. So ask me after this. So log of 4 to the power of 3. And what is 4 to the power of 3? Log of, 64. Oh, 64. So either of those are fine. I prefer log of 64. It lets me know that you know your cubes really well. And if you don't know your cubes, they're up there. Arrow made that nice little colorful chart. I'm going to make her improve that. In fact, I should have talked to her in the hallway just then. We're on to number 17. We're talking about zeros, vertical asymptotes, and removable discontinuities. So if I have zeros, I'm talking about the top equal to 0. So if I have a fraction, I don't know what's down there, but the top is equal to 0. Maybe that's confusing with circles and squares. But if I have a fraction, I don't know. I don't care what's down there, but the 0 is on the top. Vertical asymptote means the 0's on the bottom. I don't care what's on the top. And removable discontinuity, that means I have a 0 on the top and the bottom. By the way, if I have a removable discontinuity, a top in the bottom, and I still have a vertical asymptote, the vertical asymptote triumphs. If I have a removable discontinuity, but I still have a 0 on the top, the removable discontinuity triumphs. So you kind of have to know which one is more powerful. The most powerful of them all, to rule them all, is the vertical asymptotes. Vertical, and then next is removable discontinuities, and zeros is the least powerful in terms of how they affect your equation. So first we need to factor. I need to factor the top using Ninja Star in my head. What multiplies to negative 11 and adds to 10? That's x something, x something.
10 and 1.
10 and 1, yeah. Which one is positive, which one is negative? Oh, it's not 10 and 1. What multiplies to 11?
Oh, nothing. Wait. Yeah, nothing multiplies.
Yes, 1 and negative 11.
11.
Yeah, or what am I doing? I'm going backwards. It's negative 1 plus 11. There we go. Because this is a positive term, that's why I know that the larger number needs to be positive. And in the denominator, we still have this x minus 11. So if I plug in x is equal to negative 11, that makes this x plus 11 a 0, which means I have a 0 only on the top. If I have a 0 only on the top, that is a 0. If I plug in 1, that will make this top a 0 as well. So that again is a, that again is a 0. And if I plug in 11, that makes the denominator 0. When the denominator is 0, that is the vertical asymptote. All right, moving on to the next question then, number 18. All right, I need to find the coordinates equal to the cosine of 50. So 50 degrees is right there, so it's obviously A. This would have been like something like 200, or no, that would be 130, 120, something around there. And down here, that would have been something closer to 330. So it's A, but is it cosine? Is that the x or the y coordinate?
X.
It is the x coordinate. So x coordinate of A is the correct answer. Correct answer is A. Moving on to number 19. What is the value of the x coordinate of point A? So x coordinate is that sine or cosine?
Nowhere.
X coordinate is cosine. And it's not pi over 6 because I'm talking about this whole angle. You always start your angle over here on the 0 for the x-axis, or the 0 for the real, whatever you want to call this thing. Chris, question?
Can I get water, please?
Nope, sorry. So this whole angle, I have to not only add the pi over 6. This angle right here is a 90-degree angle, or you can think of that as a pi over 2-degree angle. So this whole angle, I have to add pi over 2 with pi over 6, which means I can multiply this one by 3 over 3. And this is really 3 pi over 6. 3 pi over 6 is the same thing as pi over 2. I can add 3 pi over 6 with pi over 6, and I get 4 pi over 6, which reduces to 2 pi over 3. And we're doing cosine of that 2 pi over 3. The correct answer is F. Again, you can just memorize, hey, that spot right there is 2 pi over 3. That spot right there is pi over 3. That spot down here is 4 pi over 3. That spot down here is 5 pi over 3. Having your coordinates memorized is really, really helpful in AP Calculus, Precalculus, all this stuff. There's a reason why I'm making you memorize this. Yes, you get a giant note card, 8.5 by 11 sheet of paper to just draw them all out, right? Easy peasy. All right, so number 20. I need to label pi over 3 and 7 pi over 6 on this unit circle. Everyone right now, arms. Where is pi over 3? Point. Where is pi over 3? It should be not too shallow, but nice and steep. Yeah, you guys have it. Pi over 3 is this one right here. So label that one as pi over 3. Again, no, there we go. Pi over 3. This one is pi over 6. That one was pi over 4. This one was 2 pi over 3. This one is 3 pi over 4. That's pi over 2. You guys should know all of these just kind of off the top of your head by now.
All right, test me real quick. Ready? I got this.
All right, point to 11 pi over 6.
Oof, the one in the middle right there.
Nope.
The top one. The top
Nope.
one. The top one. The top. Right there. Right there.
Nope.
Right there. Like below the line. Right below the line. Right below the line. Right there. Yeah.
Anyway, 7 pi over 6. Everyone point. 7 pi over 6. Good. Ooh, so fast, so fast. 7 pi over 6. 7 pi over 6 is right there, yeah. This is 7 pi over 6. Nice. Again, just have these memorized. You might be able to write it down for your note card and you're like, oh, I don't need to memorize this. You will need it later. Learn it now. Now is a good time to learn it. You don't want to have to learn this stuff on top of the new stuff that I'm going to be teaching you next year. I'm expecting you to have this memorized for next year. If you have to learn this again, it's going to be hard. Okay, so to number 21, special right triangle. I have a 30, 60, 90, obviously, because it's a 30, 60, 90-degree triangle. We have our living textbook up here, our classroom, which means I need to get from this 9 to here and then from here to here. So how do I get from the hypotenuse to the short leg? What operation do I do to get from this hypotenuse to the short leg? I divide by 2. So this is going to be 9 over 2. But then I have to go from 9 over 2 from the short leg to the long leg. What operation do I do from the short leg to the long leg? I multiply by square root of 3. Again, this is just something that I hope that you guys have memorized. This is also super, super valuable for the SAT if you guys had to take that or have to take that. It's also very, very valuable for, I guess you don't really use it too much in AP Calculus. You do use it in terms of the unit circle, though. And like you use it for problems like number 22. You need to know what cosine of 2 pi over 3 is, just like off the top of your head. Ready, go. Cosine of 2 pi over 3. You guys will all shout out.
2.
Negative a half. Okay.
Square root of 2 over 2. Friction?
So, cosine.
Remember these.
Again, it's just practice over and over again. You guys have now fallen down that curve of forgetting, right, that we've talked about at the beginning of the year. Now you're going to go back up and remember because you say, okay, 2 pi over 3. Everyone's going to point to it. Go. Point to 2 pi over 3. All right, so we point to 2 pi over 3. Everyone do that again. 2 pi over 3. Most of you have it. Yeah, so 2 pi over 3. If I were drawing that on my coordinate plane, it is right there. Not right there, but definitely on the top part. All right, so I have 2 pi over 3, and I can kind of enlarge that triangle now, so make this slightly larger. We had to use the paper. So if I make my triangle would look like this. So I have that angle, it comes down here, and I know that this is a 60-degree angle, which means I label my special right triangle on my unit circle. This hypotenuse I don't care about is 1. What is the height here?
2.
Come on, you guys have this. You had it memorized.
30?
Did? We have a lot of things memorized.
1 over 2.
Teachers stuff.
So look up there on your poster. It used to be the square root of 3, but it's now the square root of 3 over 2.
Woo!
This length used to be -1 because I'm going to the left, but now it's -1 over 2. There it is. So if I'm asking for cosine, am I asking for the x or the y coordinate? The x coordinate. And what is the x coordinate up here? 1/2. That's how I got a half.
This is confusing.
This is too confusing.
Yeah, it's like
Go back and look at your notes. Go back and watch those videos that I uploaded, right? All right. Now, I'm going to give you 10 seconds to do this. So, sine of 5 pi over 3. So, where's sine of 5 pi over 3?
Square root of 3 over 2.
what?
Cheater. I saw you.
Everyone, now point. Right now, everyone point to 5 pi over 3. Oh, dear God, no.
Go that way. I don't know. I'm just copying everybody.
All right. Pi over 3, 2 pi over 3, 3 pi over 3. That's pi, right? 4 pi over 3, 5 pi over 3. Not too high, nice and low. 5 pi over 3 is the right bottom. So 5 pi over 3, if I'm coming from my origin, I go down to the bottom right, and there is my triangle. My triangle goes right 1/2, and down how much? How much do I go down? Negative.
Half? 1. X. 3 over 2. At least I didn't bring basic sense to me.
Sine is asking for the x or the y coordinate. And that is y. Pun intended. The answer is negative square root of 3 over 2.
Why?
I need everyone right now, if you didn't have a note card, give me a fist of 5. How well could you do this type of problem on the final? I see a -1, a 0, a 1,
Like not bad,
a 0.
not good.
I don't even know what these are.
Please review this in your notes later. All right, we're going on to the next question.
We're pulling zero and Bruno.
What was she bring?
Make a giant poster that goes 2 to the power of 4 all the way through.
All time I said airman baited me.
Yeah, make it look nice. As big as possible. So type in all that stuff and make it nice and large.
Yeah.
Number 23, complete the point slope equation. All right, point slope form is the general form looks like this. Y minus y1 is equal to the slope m times the quantity of x minus x1. We already have our y1. Our y1 is 6, so that means we're obviously using this point. We're not using 1, 1 because otherwise the y coordinate would have been 1. This y coordinate is 6. So we know which point we're using. I'll leave that circled. We're using the point -2, 6. I need to find the slope. And then once I find the slope, then I can plug everything else in. So how do I find slope? What is the definition of slope? You will all shout out, it's... Yeah, rise over run, delta y over x, yeah. So you can say rise over run. If you like that definition, you can say delta y over delta x. In Algebra 1 this year, we're calling it Kira's formula because she loves it more than anyone else, and it's y2 minus y1 all over x2 minus x1. Kira loves that formula, so that's Kira's formula for the year. Y2 is this coordinate. Y2 means the y coordinate of the second point, so this one will turn into 1 minus 6 all divided by 1 minus -2. And when you do that, you get -5 in the numerator, and you get 1 plus 2 in the denominator, which is 3 in the denominator. Therefore, the slope here, this m, is -5 over 3.
Wow, Mrs. Suya. You know, the way you do your math is just so...
I appreciate that compliment. Thank you, Chris.
Now you appreciate it.
Well, else?
So you guys can help me do this too, but every time that I have an interaction with any one of you individually and as a class, I should be giving you 5 compliments for every 1 redirect.
Wait, English? What do you mean?
5 good things, 1 bad thing per each of you. So if I'm giving you mostly bad things, say, can you give me some more praise?
Give me more compliments, please.
If you earn it, I will give it to you. I will try my best to identify the good things that you guys are doing. All right. Thank you for smiling, Chris. All right, x minus. You have a good smile, Chris. It is true. That is a legit compliment. All right, what is our x coordinate? Someone shout it out. Our x coordinate is.
What?
I filled in our slope here, right? M is -5/3.
Oh.
X minus, and my y coordinate was 6, so my x coordinate therefore is.
-2.
Yeah, -2. Thank you, Andrea. Woohoo! And again, if I have a double negative, you guys can shout that out. It's going to be positive. So it's really y equals, or y minus 6 is equal to -5/3 x plus 2.
Gears are turning. Yeah. I kicked it in.
All right. How do you guys feel about point slope form, fist of 5?
I would just leave it like that.
3.5.
Yep, done.
Why give myself?
Oh, much higher score than using all of our trig.
Yeah,
Not everyone voted, but that's okay. Okay, this guy can be difficult. I know that we struggled with him a little bit in the past. Solve for z when we have radical equations. You will be seeing these in BC calculus next year.
Ow.
The way that you solve these is you first get only the radical, only the square root on the right side. So let's add 3 to both sides, and I now get z plus 5 is equal to that square root of 2z squared plus 3z plus 7. That's all under that radical sign. Radical. I'm adding 3 to both sides, so I'm moving that 3 over and combining it with a 2. Yeah, good question. I should show my work better, right? Plus 3, plus 3. That's how I got that. All right, now, how do I undo a square root? You guys will shout out, you square it. Yeah, good job, guys. So square it. I get now no more square root because I squared it, and I have just 2z squared plus 3z plus 7 all by itself. No square root anymore. But on the left side, I have to square both sides, so I still have z plus 5 quantity squared. And that's the part that kind of trips us up. We're like, oh, shoot, what's that shortcut for squaring it? I'll show you the long way, and then I'll show you the shortcut. The long way is multiplying it out. I mean, that z plus 5 is the same thing. Z plus 5 quantity squared is the same thing as z plus 5 times z plus 5, which means I can use my area model or my general rectangle, whatever you want to call it. This thing that says I have z plus 5, z, that's a z right there, plus 5, and I say z times z is z squared. Z times 5 is 5z. Z times 5 is 5z. Z 5 times 5 is 25. I add up all that area and I say, okay, that's clearly z squared plus 10z plus 25. And I need to stop using the word clearly because that might not be clear.
That's not even a word, is it?
It is.
Anyways.
Clearly the answer is 5.
Wait, why isn't anyways a word?
I think it is now. It just used to not be, and
It's like,
it was a
if
pet
you're
peeve of
like
mine.
talking, you can be like,
Anyways.
continue the subject. you can be like,
Anyways, back to the
anyways,
point.
yeah, like.
Anyway, back to the point.
No one says anyway.
Anyways, like the
anyways.
original word.
Vanessa? That's
Who's Vanessa?
You can call me by my middle name and Sean.
And the right hand side is still the same. It's still 2z squared plus 3z plus 7. From there, I need to get all of the squares and stuff on the right, or on the same side. I'm going to choose the right side because if I subtract z squared, I'm going to be left with a positive leading coefficient. If your leading coefficient is not positive, then your factoring will have a high chance of failing unless you really know what you're doing. So that's why I'm going to move to the right side. I'm going to subtract z squared from both sides minus z squared. I'm going to subtract that 10z, subtract the 10z, and of course subtract the 25. Subtract the 25. When I do that, I'm getting rid of all this side. That's now just a 0 on the left-hand side. The right-hand side, I have a positive z squared, I have a negative 7z, and I have a negative math. I'm going to go up to 3, then I need to go up 15 more, so at negative 18. Now the question is, how do I solve? Because the whole idea is here, I'm solving, so I need to factor this thing, use the zero product property, and actually find a value of z that makes this thing 0. So I'm doing a ninja star in my head, or you can do it on paper as well. The ninja star, what adds to negative 7 that multiplies to negative 18? The first question, what times what is negative 18? 1 and 18.
2 and 9.
Ah, 2 and 9 would work. Which one would have to be negative? Negative 9. There it is. So I factor this now as z plus 2 and z minus 9. Chris, have you written all this down already?
Yes, sir.
You've written 0 is equal to the quantity of z minus 2 times the quantity of z minus 9.
Dang, and he's not lying.
Nice. You're fast. Therefore, Chris, our answer is z is equal to...
2 minus 9, yeah.
2 minus 9? Not quite. I'm kind of changing the sign here to make it negative 2, and z is also equal to positive 9. What I'm really doing is I'm skipping a step. What I'm really doing, if I move this down to show the step that I skipped, I'm really saying that this z plus 2 has to be equal to 0, and that this z minus 9 has to be equal to 0, because this could be 0 or this could be 0 in order for them to multiply to 0. I'm using the 0 product property, and then therefore I get my answers, I can box them, and I'm done. Yeah, that had a lot of work, and that's why I'm going to probably make this one more points, not just 4, probably add 5 or something. The reason that there are weird points in the bottom right is I copied and pasted from your test. This was a test question. Or maybe a pre-test question. All right, we are on to the next page. Page number 5. Now we're doing derivatives. This is a hot box technique, which means...
This is the kind of thing that you could draw, and by hand it would really fun. It's very confusing.
Okay, if you can make it look really nice, if you hand draw it, then that's totally cool with me. Just make sure it's clear from a distance. Hot box, someone help me out.
You circle the thingy.
Yeah. Box, the top left area, the thing that's being added h. So I say my c value is the thing being added h, which is e. Then I cross everything out in here, and my function, my f of x, is that whatever's in the hot box, so the natural log of x. That's all I needed to do. I'm done. That's it. I found my function, natural log of x. I know what point I'm evaluating at. So what point am I evaluating? 1, 0, e. I'm evaluating at e, so I cross off c, d, and e. I'm evaluating at e. I'm taking the derivative. And what was our function? Our function is not natural log of x over x. It's just natural log of x. Correct answer is A. Sounds good. Can you get like a lot of it so I can get some more too? I'm out. Thank you. Number 26. All right, I'm taking the derivative. I'm kind of doing the distributive rule. I'm saying the derivative of that one, and that one. The problem is we have these gross, ugly fractions. We don't like fractions when we're talking about derivatives or antiderivatives for that matter. So go ahead and rewrite this as the derivative. I still have to rewrite the derivative because I haven't taken the derivative yet. The derivative of x to the negative 3 minus x to the negative 1 plus x squared. Look, all of the fractions have gone away. Whoosh. Now I can actually take the derivative. If I take the derivative, this negative 3 comes down in front. I have negative 3x to the power of what? Yes, negative 4. Thank you, Teflon. It goes down a power. And I'm going to bring this negative 1 down in front. Negative times a negative is a positive. So I'm going to do positive x to the power of what? Negative 2, exactly. I'm going down. You always go down a power. And then plus 2x to the power of 1, or you can just leave it as 2x. I'm not done because I now need to let arrow in and then plug in x is equal to negative 1. It says at x equals negative 1, what is that value? So I think even before I plug in that negative 1, I'm going to rewrite these because what does it mean to be to a power of a negative? I'm going to rewrite this backwards as a fraction now. I'm going to say that is equal to, it was negative 3x to the negative 4. Now it's negative 3 over x to the power of positive 4. Everyone see how I got from the yellow negative 3x to the negative 4 to the green negative 3 over x to the power of positive 4? We're all okay with that step? Again, remember that the coefficient stays behind. It's only the variable that moves between the numerator and denominator. Then I'm going to do plus 1 over x squared and plus 2x.
So I just have to put these.
It's negative 3 over.
Say again?
I just have to put these numbers in.
Yes, because I don't care anything. I don't care about squares and cubes since they're already up there.
So it's negative 3 over the power of 4.
Negative 3 to the power, negative 3 over x to the power of 4. Yeah, the x moved down. All right, and that's going to be evaluated at x equals negative 1. So when we plug in negative 1, I get negative 3 over negative 1 quantity to the power of 4 plus 1 over negative 1 to the power of 2 plus 2 times negative 1. And then just doing a little bit more simplification, negative 1 to the power of 4 is just 1. So you can kind of ignore that. Negative 1 to the power of 2 is also 1. So my answer is going to be negative 3 plus 1 minus 2. So the answer is negative 4b. Now is the time where you ask questions. All right, we're moving on to number 27. This guy is hard. Whenever I take the derivative, I always multiply doubter times dinner. Exactly. Thank you, guys. So my doubter is technically the doubter of the inner. So when I take the derivative, I'm saying, hey, take the derivative, and then once I take the derivative, plug in 1. So if I take the derivative of this h, that's what I'm doing, I'm going to do doubter. So the derivative of the outer is f, so here's the derivative of the outer. And then I have to rewrite the inner of g of x. Then, Chris, I can multiply by the dinner. And the inner is g of x, so the dinner, Chris, therefore is... If the inner is g of x, the derivative of g of x is g prime of x. You were close. All the right. So from there, I'm going to plug in 1, which means this is now, this x is a 1, this x is a 1. I now need to rewrite this and say, okay, well, what is g of 1? This thing that I circled in green here, what is g of 1? And you're like, oh, g of 1 is 3. So I can rewrite this as f prime of 3 times, and again, now I'm looking at g prime of 1. G prime of 1, I circle right here, is negative 3, so I can say this is times negative 3. But I'm not done yet, because I now need to do what is f prime of 3. This f prime of 3 is this f prime of 3, which is negative 5. I can circle that a little bit more clearly. So that means that this is now equal to negative 5 times negative 3, which is equal to positive 15. Correct answer is B. All right. We are moving on to the next question, number 28. I have E house. What is the inner of E house?
E house.
The doubter of E house is E house, but what is the inner of E house? It's whatever the exponent is. So the inner is just 1 over x. So if I'm taking the derivative, I'm going to do doubter. So doubter of E house is just E house. It's one of those nice ones. So here's your doubter, e to the 1 over x. Done. But now I need to multiply by the dinner, which means the derivative of the inner, the derivative of 1 over x. I can't do the derivative of 1 over x by itself. I need to convert 1 over x into a fraction, or into a non-fraction. So 1 over x is the same thing as x to the negative 1. So if I take the derivative of this inner, again, this is the same inner. If I take the derivative of this x to the negative 1, the negative 1 comes down in front, and it goes down a power, x to the negative 2. There it is. That's the answer. Doubter times dinner. The only difference was I had to change my inner so I could actually take the derivative. When I have x to the negative 2, that means I really have everything divided by x squared. So the correct answer here is D. It has that e to the 1 over x in the top, and this... Oh, it's not D. No, it's A. I forgot the negative. There's this negative 1 out front. I should have paused to let you guys be able to catch the error, so you could have got the XP and the extra credit. Yeah, so the correct answer was A. It has the negative, it has the e to the 1 over x in the numerator, and this x to the positive 2 here in the numerator. All right, we're on to number 29. We have cosine to the power of, or cosine cubed of 4x. I can rewrite this thing. Everyone rewrite it now. This is cosine of 4x. And that quantity, I'll put it in square brackets, is to the power of 3. So my most outer house, I like the dance. The most outer house is powerhouse. Powerhouse means I'm going to make that 3 come down in front. And this is now going to be times cosine of 4x. I can't touch the inner, not yet. And that's to the power of 2. It goes down to power. Does everyone see how I took the derivative and got down here? We're okay? Ask me a question. What happened to the negative? Oh yeah, I haven't touched the cosine yet. The cosine of 4x has not been taken the derivative of. I did not say that correct, but I think you guys can understand it. Now I'm going to take the derivative of cosine. First, I'm going to do doubter, and now I'm going to do dinner, where I'm going to have the change. C stands for change, so I'm going to do times negative sine of 4x. But there's still something that I haven't touched. I still have not touched this 4x. So now I'm going to do the dinner inner. The derivative of that 4x is 4. So my most outside coefficient, I should have a 3, a negative, and a 4. All of those things get multiplied to a negative 12. Do I see a negative 12 out here? Aha, I do. It is a B. Again, I did the doubter, dinner, dinner inner. No one's asking a question. No one's raising their hand. I'm assuming I can move on to number 30.
No, wait.
Wait, yes.
Dang, how long is this package? Jesus.
We're almost there. What time do we get out of here on a Thursday, by the way?
2.
Yeah. All right. Well, that's gonna be our last problem then.
Wish I could memorize my tests. Like how
Yeah.
the times I
I
get
know.
out of class.
To get out to lunch.
We are on our final page then.